In this video, I'm going to correct my mistakes that I did in the Model 4 exam. So the first question that I got wrong was, the base of a common logarithm is, and I put the option that said A, but that is wrong. The correct answer is 10 because we all know the logarithm always has the base value of 10. Question I got wrong was this problem. So the problem says to rewrite the expression as a sum or difference of logarithms. So I'm going to show you the correct procedure that it had to have. Was to get rid of the fraction here. So to get rid of it, we have to do a difference of logarithms. So here I separated log 13 from the numerator and log 13 from the denominator, so it resulted this. Here we have a multiplication of these values. So to get rid of the multiplication, we do a sum of logarithms. So we will pass it as the same, and we will just separate the s squared from the r, like this. As we can see here, the negative sign is multiplying all this. So here we are left with minus times plus, so we will leave minus. And here the negative sign is also multiplying a positive sign, so here we are left with a negative sign. So now the next step is to get rid of the exponential signs, but first we have to convert this square root into a exponent sign. This is how it looks converted into an exponential sign. So now all we have to do is get rid of the exponential signs by passing them into the initial logarithm. So here all I did was the exponent, I took it on the front side of the logarithm. So here, 1/2, I put here, s squared, I put it here, 2, and this will be our answer. The next problem that I got wrong. So, also here it says to expand the logarithm expression as much as possible and to write the exponents as factors. So what I got wrong here was that I didn't really write the exponents as factors. I only did some of them, but I got wrong one of them. So the correct procedure is the following. What I had to do is to get rid of the fraction here. So to get rid of it, we know we have to do a difference of logarithms. So we separated this and this. So this is what we are left off with a negative sign. So the next step was to, well, as we can see here, this value is multiplying from this value. So we are going to separate it by doing a sum of logarithms. We are left off, we separated this from this, and we got a sum of logarithms. And we just, also, here I forgot an exponent. we got rid of the exponent and we put it right here. So now we have to also, as we did before, we have to get rid of the square root. So here we are left off with an exponent of 1/3. All we have to do is get rid of the exponents and put it as factors. See, here we already have written the exponents as factors. So this would be our final answer. So this is the next problem I got wrong. I got it wrong because I did a division instead of a difference of terms. So what I'm going to show the right procedure. So the first thing is to add a natural logarithm to both sides of the equation, is to bring the exponent as factor. The next step is to multiply this term by ln(e). See, I multiplied x times ln(e) and 7 times ln(e). So the next step is, well, as you can see, ln(e) can be eliminated because, as we all know, ln(e) is equal to 1. So we are left off with x plus 7 is equal to natural logarithm of 4. So now all we have to do is to have the x left only on the one side. So here the 7 has to transfer into the other side, as you can see right here. So the problem states that we have to express the solution set in terms of natural logarithms and as a decimal rounded to 3 decimal places. So I'm just going to type this on the calculator. The calculator gave me this value, and as you can see, this and this can be both our answers. So the next problem I got wrong was this one, because I didn't multiply a factor as it had to be. And so I'm going to show the right procedure. So the first step is to have all the logarithms in one side, like I'm going to show you. It was negative, and as I took it to the other side, it turned into positive. So now what I'm going to do is to this is a procedure in which is different, like the contrary of what we did on the past procedures. Instead of having the expressions turned into sum or difference of logarithms, we're going to do the opposite. So here we have a sum, so we are going to unite them as a multiplication. Then the next step is to get rid of the logarithm. So I'm going to pass the logarithm over here, and we are left off with. So now we are just going to convert the 6 to the 3rd. So we're going to solve it, and we are left off with 216. So now the next step is to pass the 216 to the other side. And equal it to 0. And now we are just going to multiply it so we can have an equation. So now all we have to do is to find two numbers that multiplicated give us negative 216, and summed 6. So the two numbers are positive 18 and negative 12. So as we all know, in the answer, the signs change. So we have negative 18 and positive 12. And as we all know, the answer cannot be a negative. So this one is not our answer. 12 is our answer. Next problem I had wrong, and it is very easy, but I got confused and I divided it instead of bringing it as an exponent. So all I had to do was do 3 to the 4th power. So x is equal to 3 to the 4th power, and that would give us 81. So 81 is our answer. So the next function that I got wrong was this one, and I got wrong its domain and its x-intercept. So all I had to do was first factor the function. So it would then by the denominator I had to give the domain. So I just had to get the value of x, of both x's. So it would be x is equal to 5 and x is equal to minus 4. So our domain would be x such that x is not equal to 5 nor to minus 4. So this is our domain. And to get the x-intercept, so I had to look at the numerator and equal x to 0. But here we have a whole, as you can see, x plus 4 in the numerator and x plus 4 in the denominator. So all we are left off with x minus 3. So x minus 3 is equal to 0. So x would be equal to 3. So our x-intercept would be 3, 0. And that would be our answer.